So this is my fifth assignment. First of all, I'm doing the data pre-processing. Here I'm showing all the important information, and then I dropped the state column because there were no values, so all the values in there were NA, so I don't have it, I don't need it. And then I'm dropping the duplicated values. First of all, I'm checking it, and then I'm dropping all the duplicate values, and then I'm making a new column which is called date, with date time, with year, month, and day information. And then I'm sorting it, and that's all for data pre-processing. And now I'm doing time series analysis. First of all, I'm filtering data for one city, which is Abidjan in my case, and aggregating the daily temperature to avoid duplicates because I'm making indexes for frequency. And then I'm visualizing the time series. So this is my time series of average temperature in Abidjan. And after that, I'm decomposing with seasonal decomposing the time series. And after that, I'm doing the ETS, which is exponential smoothing model. This is the ETS forecasting for Abidjan, and N is equal to 34, which means the 30 days. And then I'm doing the simple ARIMA example of ARIMA model. So this is my ARIMA forecast for Abidjan, and then I'm calculating the error metrics, which are for ETS model is 72 and 55 is MSE, and ARIMA model, as you can see, is more better than ETS model. But ETS model is actually, I don't think it's really bad, but ARIMA model is really good and really better than my ETS model. So I'm doing the predictive analytics. So the city daily, DF city daily is already created. I'm just copying it, and then I'm creating the features, which are the lag features, for example, for previous 1, 2, and 3 days. And then I have rolling features, and then day of the weeks, where 0 will be the Monday and the 6 will be the Sunday. And then I'm dropping the NA values in DF features dataset, data frame, I mean. And then I'm preparing the X and Y. X will be all the values except temperature, and the Y will be the temperature itself. And then I'm splitting the dataset into two parts, train and test. Train will be the 80% and test will be the 20% of the whole dataset. And then I'm doing the KNN value with elbow method, so it will search for the best K value, and then it will use this best K value with lowest MSE for KNN model. So here you can see the visualization. So the best K value in my case will be the 18 with lowest MSE, which is the 166.44. And then I'm doing the linear regression model, and for my linear regression model, MSE was 192.41. And then I'm doing the predictions for sample observations. For example, my actual temperature was 81 and 30 degree, and KNN predicted temperature like 83.19, and linear regression predicted 82.13. So I think the differences are not high between them. Now I'm doing the visualization and reporting part. First of all, I'm aligning the lengths. For example, for forecasts, I'm making sure that forecasts aligns to test set, and then because it's important for visualization. And then I'm plotting the actual and predicting for all models. My dataset is really large, I think. Because of that, the visualization is not beautiful. but you can see some trends. The black line is my actual data set, and I think the linear regression is doing really good. The ETS forecast is going up and down really high, and ARIMA forecast, the green one, you can see it somewhere. And then what else? And then KNN predictions. I think it's all of the models doing really good except ETS forecast. That's all.